Welcome to today's lesson. And so my name is Samasaka Kirendens. I'm going to take you through organic chemistry. And today we'll look at how actually we can separate crude oil into fractions, into different components, or into producing actually different products from crude oil. And so we go through the lesson for today. Well, fuels are actually made from crude oil, which is a mixture of hydrocarbons. And so we are aware that hydrocarbons actually, because they do not have double bonds, and so they burn very much, and so that's why they are used as fuels. And so methane is the main constituent of actual natural gas. It's very important to know that methane is the main constituent of natural gas. And the crude oil can be actually separated into fractions, having different boiling points and a different number of carbon atoms. And so we will look at dearly how we can ensure that we separate this crude oil into different fractions. And this is what is known as fractional distillation. And so we'll give a brief background on really how we can separate the crude oil into fractions. Okay, so this is the fractional column, which is basically used for fractional distillation of crude oil. Well, at the base here, the petroleum is actually pumped in, and then it will definitely have the highest temperature here where it is being burnt. And therefore, we actually produce the residue down here, which is known as bitumen. And bitumen actually is used in making rods. As well, at 500 degrees, we have lubricating oil, which is actually used as a lubricant. And so I've just selected actually the maximum temperatures here. It is actually a range. So up to 340 degrees Celsius, we have the collection of diesel as a fraction. Diesel, we are aware that is used in motor fuel. And at up to 250 degrees Celsius, we have paraffin or kerosene, which is used in jet fuel. And at 170 degrees Celsius, we have naphtha, which is used for making actually chemicals in industries. And at 75 degrees Celsius, we have petrol or gasoline, which is also used for motor fuel. And then lastly, at 25 degrees Celsius, we have petroleum gases, which are actually used for cooking. And so this fraction arrangement is very important to know. We need to know exactly which one comes at which temperature. And because many of these questions are actually asked. So at the bottom again, I'm going to briefly look at the arrangement. We have bitumen, lubricating oil, diesel, kerosene, naphtha, paraffin or gasoline, and petroleum gases. Okay, in that order. And so here I'm just looking at the product which we produce, which we've looked at here, and really the state in which it is, and also the number of carbon atoms. And we realize that bitumen actually is a solid, that's why it's used on rods. And the number of carbon atoms are greater than 70, while fuel oil, which is a liquid, it is between 70 and 20 carbon atoms. Lubricating oil is a liquid, which has between 20 to 50 actually carbon atoms. diesel is a liquid collected as liquid in a fraction form, which has 12 or more carbon atoms, and these are actually alkanes. Then paraffin or kerosene is a liquid. It has 10 to 18 carbon atoms. Then gasoline or petrol is a liquid. It has actually 5 to 12 carbon atoms. And then naphtha is a gas. It has 5 to 9 carbon atoms. And petroleum gas is a gas. It has carbon atoms 1 to 4. And so the major components of crude oil are actually been given here. And now we look at actually the boiling points, which we looked at earlier, as well as the uses, which I've already outlined. And so today I thought we would look at how crude oil can be actually separated into fractions, and it will give these necessary uses. And so I thank you for this lesson for today. I hope you are going to actually subscribe to my YouTube so that you can get more of this lesson. Thank you.